Right, in the interest of time, we'll get started. Welcome everybody to the first of Steiner's Tech Talks that we're going to be kicking off. Today is the first one we've ever done. And today we're going to have myself, Rob Elliott, and Kevin from PIP, who'll be providing a lot of information about hearing protection, something we don't always think about, but definitely something that's super critical. Kind of just give a little bit of an overview of what we're doing. And I don't know why there we go. The whole purpose of Steiner Tech Talks moving forward is really just to be a monthly webinar series, 30 minutes, trying to connect experts outside of the Chicago area that provide insights and innovations and new ideas with our customer base here in Chicago. Going to be a wide range of topics that are relevant to commercial construction, end users, OEMs, and the metalworking. So it's going to be a different topic each week. And definitely there will be a recording at the end that we can share and build out a library for people to participate and view as needed. This month is National Safety Month. And so in alignment with that, we thought we would go over a topic that was definitely related to safety. And with that, we have today's expert, which is Kevin, who has a wide variety of experience in the industry, all sorts of sectors, including several certifications. So we figured he was the best person today to talk about safety and hearing protection. And Kevin, if there's any more you'd like to share with that or anything on it, I'm sure you can get into your presentation of what your background is, but we'll dive into the topic of what we wanted to talk about today.
Yeah, that sounds great. Thanks, Rob. Like you said, my name's Kevin Czechorski. I am the product sales manager for PIP for our North Central region, including the Chicagoland area. And I cover everything what we consider above the neck products. So from hearing protection, what we're going to talk about today, to eyewear, head protection, respiratory, and basically if it's PPE that you wear anywhere on your head, above your shoulders, above the neck, I'm your guy. So we're going to spend some time today really concentrating on how we want to talk about and understand hearing loss prevention, right? We're not just trying to conserve the hearing that our folks have left. We want to prevent them from losing any of their hearing to start with. So with that, we can dive right in. Go on next, Rob. So we're going to start off just a quick agenda. We're going to start off with some statistics and some definitions, just so we're all on the same page. When I use, specific terms, we understand what I'm talking about. Then we're going to dive into a little bit of the science of sound and how we actually measure sound. That's kind of one of the most common misconceptions, right? Is people misunderstand how we're measuring sound. So we really want to get a good baseline of that so that we know what it is that we're actually protecting against. And from there, we'll dive into actual hearing loss prevention, go over some of the standards and regulations, some components of the hearing conservation programs, and then how to properly fit and use an HPD or hearing protection device. Next. So why do we care, right? When we think about safety, usually we think about the higher risk categories, things like fall protection. If I fall from a tall height, I could get paralyzed or even pass away. When we think about respiratory protection, these really high risk, high hazard things. And because of that, hearing protection kind of takes a backseat usually in a lot of people's minds because it's not an immediate instant hazard, right? It's not something that happens where damage occurs right away if your first experience overexposure to noise. It's progressive, right? So every time you're exposed to damaging sound, it continues to get worse, but it takes a really long time for you to notice that. So when we bring in some of these statistics, this is why we really want to concentrate on this, right? 8 million Americans already suffer from noise-induced hearing loss. And what this translates into, right, is that it is actually the #1 expenditure for workers' compensation claims for organizations. And the last data that we have reported for these stats was in 2021. And at that time, we were spending as a nation $242 million a year on workers' compensation for hearing loss disability because it's a permanent disability, right? It's not like you fall and break your leg, you go to the hospital, you get a bill, and a year later you're walking and everything's fine. Once you experience noise-induced hearing loss, it's a permanent disability. So that's why those costs are so high. So we really want to be able to protect, obviously not just our bottom line, although that helps, but really because it's a permanent disability, we want to make sure that our folks, when they get older, when they get to that retirement age, they can still hear the sounds that they want to hear. So next.
Now, Kevin, do you feel like it's also the frequency at which you're in these high decibel levels that, if you happen to and you're in it for a couple minutes, you don't really think about it because you're like, oh, it was only a couple minutes, but are there times where even a few minute exposure over a long period of time really does build up?
Absolutely. And we'll get into a little bit of that on in the next couple of slides. But that what we do, the way we measure sound, right, was actually use a time-weighted average for the permissible exposure limit. So you can be in noisy environments for short periods of time, but if you're in those noisy environments for a lot of short periods of time, they add up to whereas if you were in a noisy environment for a long period of time, it compounds on top of each other. So it's a time-weighted average of noise that we have to be cognizant of. And that includes both noises at the workplace as well as at home. And we'll give some examples of that as we move on. That's a great question, Rob. So I'm going to read through this real fast, but this is just to make sure we're all on the same page with some basic definitions. Anytime we say sound, the way we want to think about sound is that it's vibrations that cause variations in air pressure. A really, really easy way to think about it is that sound is energy. Okay, we're just thinking about our sound is energy. Noise is just unwanted sound. Decibels are the unit that we use to measure the intensity of a sound. TWA, or time-weighted average, is the average measure of exposure given over a given period of time. Noise-induced hearing loss is damage to the ear caused by overexposure to sound, resulting in the loss of ability to hear. PEL, or permissible exposure limit, is the maximum exposure allowed before potential injury occurs. I'll use the word attenuation a lot today in this training and anytime you talk to me probably, but when I say that, it's just a reduction of noise. That's all we're talking about, is how much noise we're able to reduce from reaching your ear. HPD, or hearing protection device, is a device that lowers noise exposure by blocking some of the sound before it enters the ear. NRR, or noise reduction rating, is a laboratory estimate of the amount of attenuation achievable by an HPD. And a PAR, or a personalized attenuation rating, is the actual amount of attenuation achieved by a specific HPD on a specific individual. So that's our baseline. If you've got any questions or if you can't remember terms, we added this right in here so you can go back and reference it. Go ahead, Rob.
Seems straightforward.
Yep. All right. So if you take nothing else away from today, make it be this. Okay. What are decibels? They're simply a degree of loudness. Okay. We use them to measure the intensity of a sound, comparing it with a given level on a logarithmic scale. What does that mean? As a society, we are conditioned to think of numbers linearly. So if we think of two cars driving down the highway, one's going 50 miles an hour, and then a minute later, another one comes by going 53 miles an hour, that's a linear progression of speed. It's not that big of a difference, right? To the naked eye, with a minute passed in between the two cars, you probably couldn't tell which one was even going faster. That is not how we measure sound. We measure sound logarithmically, which means that for every 3 decibel increase, the sound doubles. Okay, so to use that car example again, that first car still going 50, but now that car that was going 53 miles an hour is actually going 100 miles an hour. It is twice as fast in that analogy, or twice as loud every 3 decibel increase. So if you advance one more, Rob, I should have a chart that should pop up here, and we can look and see what that looks like as a visual representation on the scale, right? So if we look at our sound baseline starting at 70 and going to 73, we see that it doubled, but because it's a relatively low baseline, it's still not that crazy. But once we get up into the 100 to 103 to 106, once we hit that 118 to 121 decibel increase, it's doubled on top of itself every time, right? It's been an exponential increase every single time. So by the time we reach the amount of energy, we're talking between 118 decibels to 121 decibels. We're talking incredibly, incredibly loud sounds with a massive jump in the amount of energy in just that 3 decibel increase.
So seeing that right now there's a whole bunch of finals going on for sporting events. And you
Yes.
always, every time you go, they always want to show you what the decibel meter is.
Yep.
Actually, you're doing a lot of damage trying to be louder to cheer on
That's
your
right.
team, apparently.
That's exactly right. It's funny. You go into a hockey stadium and they say, make it loud, right? And then they show the decibels and you're hitting that 110, peak. It's very, very loud. The good news is it's a relatively short period of time, and most people aren't exposed to that loud of noise for extended periods of time. So their ears get a chance to recover, right? Where this becomes mission critical is when we're working in a facility that, is 95, 98, 100 decibels all day for 8 hours. And then we also go to that hockey game and hit that 110 peak, right? That's when that compounding effect really starts to take place.
Okay.
All right, so how loud is too loud, right? How do we actually calculate this? If we think about our permissible exposure limit as like a dose, right? Everyone has over an 8-hour period of time, 85 decibels of average noise exposure that they could be exposed to. Problem is, the equal energy principle tells us that if we double that sound energy by going to 88 decibels, we have to cut that time in half. So if you advance one, Rob, right? So at 88 decibels, we can only be exposed for 4 hours before potential injury occurs. Hit it again, and it should take us up to 91 for 2 hours. One more time, takes us all the way up. By the time we hit that 115 decibel sound, because it's been cutting the time in half every time, you really can only be in 115 decibels for about 30 seconds before potential injury occurs. And that's over an 8-hour period. So if you're exposed to 115 decibels, at any point for 30 seconds, really for the rest of the entire day, you've got to be in a quiet environment to allow your ears a chance to recover and rest before you go into a noisy environment again. And when I say quiet, we're talking roughly 70 decibels, which is about the sound of a library, right? A quiet sound of a library. So imagine if you had to spend the rest of your day in an environment as quiet as library, no TV, no talking to your kids, no talking to your spouse, no driving in a car, right? That's really just not feasible. So that's why we really want to make sure we're protecting ourselves while we're at work, because those hazards continue after we leave. All right, next one. So this is just some examples of kind of what I was talking about, right? Is again, how loud is too loud? We're all kind of familiar with the chart on the right-hand side, and we've got a PDF version of this noise thermometer. It's a really great tool. It's a great reminder for employees to go and kind of look, hang it up in a break room. We're happy to send you guys PDF versions of this. Get you some printed copies if you'd like to have it hung up in your break room. But it's a really good reminder of, hey, it's not just the stuff we do at work that is loud. There's stuff that I have to be cognizant of when I go home, right? We're all familiar with that right-hand side of the chart. We all know that compactors are loud. We all know ambulance sirens, right? Bulldozers, fire alarms. We all know that's the stuff we're working on every day. The stuff we take for granted is, well, would you know that a regular push gas lawnmower is just as loud as that industrial fire alarm, or just about as loud as that industrial fire alarm? Or the motorcycle you ride home is, almost as loud as a semi-diesel truck. The one that always stands out to people, if you see a crying baby, can peak up to 110 decibels. And as someone that's got a 5-year-old and a 2-year-old at home right now, I can tell you they can absolutely hit that range. So this is the stuff we really want to protect ourselves while we're at work, because again, those hazards don't go away when we go home.
Yeah, and I think one of the reactions that I had looking at both sides of the chart and seeing that, hey, there was, that comparison of levels. You're at work all day, you do whatever the work is, you come back home, you got chores to do, you got things to do, and you're not really thinking about like the accumulation of everything that happened throughout the day to understand that that accumulation could spill over and you're in a very noisy environment even after work.
That's exactly right. Yep. And if we use up our entire, again, to use that dosage analogy, right? If we use our entire 85 decibels over 8 hours at work, and then we go home and even just run a blender, make a smoothie, do things that we think are keeping us healthy, we could actually be causing ourselves a potential injury.
Okay.
All right. So this is now where we get into the nuts and bolts of how we protect against that, right? So OSHA regulates they have regulations and standards for hearing conservation programs. in both 1910 for general industry and 1926 for construction. They're both very, very similar, but if you look up 1910-95 and 1926-52, those are the exact standards where you can pull exactly what they require. But these are kind of the highlights, right? So first and foremost, OSHA requires that a hearing conservation program be implemented once sound levels reach 85 decibels. Okay, that's referred to as the action level. So if anywhere in the facility at any time, whether that's a constant 85 or even just a peak of 85, if they get a machine that impacts, a stamping machine or something that hits only once every 2 minutes, but it hits over that 85, we have to implement that hearing conservation program. And I'll go over the details of a hearing conservation program, what that entails on the next slide. But they differ a little bit. These standards haven't been updated in a really long time. And so the challenge is that we can be compliant with OSHA regulations while still potentially causing injury to our employees, because they set the 8-hour time-weighted average permissible exposure limit at 90 decibels instead of 85. Okay, so yes, technically, if you're in an 89 decibel environment, OSHA says you're compliant to work there for 8 hours without hearing protection, but we know that it's actually going to cause damage to those employees. The other thing that they do that we really want to be cognizant of when we're developing our hearing conservation programs is they use a 5 decibel exchange rate. So what that means is that when you're doing your time-weighted average calculations, OSHA says you can use that sound doubling, that energy doubling every 5 decibels instead of 3, which at the low end of the spectrum doesn't seem like a big deal. But by the time we get into that, 95, 100, 105 decibel range, you can be compliant by staying exposed to those for much longer than it would take to actually potentially cause damage. So as we help develop these hearing conservation programs, anytime we get myself or any of my counterparts at PIP involved, we really try to develop these hearing conservation programs to stay below that 85 decibel threshold. Even though OSHA says you can go to 90, our goal is to actually keep people safe and protect their hearing, not just remain compliant.
Do you know if there's, and a bit of a curious question, do you know if there's anybody in OSHA working on changing these standards, or this is just going to be how they're going to view it moving for the foreseeable future?
OSHA making changes to regulations is about as difficult as it is to turn the Titanic, but
Okay.
it is being done. In fact, our friends up north in Canada, they just released a new CSA standard. We are the only industrialized nation on the planet left that still recognizes a 90 decibel time-weighted average. Everyone else has gone to the 85 decibel threshold. So that's really where we want to stay.
Okay.
All right, so that hearing conservation program, right? What does that actually mean? There are 4 main components of a hearing conservation program. The first is noise monitoring. Basically, what this means is we just need to know how loud the area is, right? We need to know what the hazard is that we need to protect against. So that measures all the noise levels in the work area. It has to include all those continuous noises as well as intermittent and impulsive sound levels, right? Because if it's a 85, 89 decibel environment, but then every couple of minutes you get a hit that it takes it up to that 105, we have to be able to take that into consideration when we do that time-weighted average, right? Because that every once in a while, those impulses, those peaks will spike that average up. Excuse me. And this is the piece of noise monitoring. Most people understand that. It's part of a hearing conservation program. We have to have that done. We need to know what that hazard is. A lot of times where we see these fall apart is that last point, is that it must be repeated whenever there's a change in the work process or the work area, because sound hazards change, right? If you build a wall in a facility, now you've got different echoes, you've got some of those sound waves, that energy bouncing off in different ways. So it could be louder or potentially quieter if we removed a wall and you're further away, right? So there's things, anytime you change the area, if you add a new machine, now you're compounding that amount of energy. So we have to do a noise monitoring assessment anytime there's a change to the work area or the work process.
And is it like over an 8-hour period, or do you have to do it over multiple days and kind of do an average over time?
Yeah, so the general rule of thumb is you use a device called a dosimeter, which takes those time-weighted average kind of calculations, build it in over about a 72-hour period in multiple areas of the facility, right, to get a full scope and picture. So There are third-party organizations that come out and offer this as a service. Typically, it could range anywhere from a week to a month of interaction with them to get the whole facility mapped out.
Okay.
All right. The second piece is audiometric testing. Okay. This is just used to evaluate whether an employee has experienced noise-induced hearing loss. So these are just those annual hearing tests. First time someone enters a hearing conservation program, we test their hearing to get a baseline. And then every year we retest to see if damage has occurred. The third component is hearing protection devices, right? This is how we actually defend against that noise-induced hearing loss. Employer must provide HPDs at no cost. This language is pulled directly from the OSHA regulation. It says employers must provide a variety of suitable HPDs. That is the language they use. What does that mean? There have been a number of different interpretations. The one thing that I can say for sure is that offering just one style of earplug does not meet a variety of suitable HPDs. So definitely don't be that guy who only has one earplug for 100 employees. Kind of a good general rule of thumb is, if you've got 50 or more employees, have at least 3 or 4 different styles of earplugs that you offer, and maybe 1 or 2 different styles of earmuffs. If you've got 5 that you're offering, that you're training your people on, that we can make sure fit and are providing that suitable protection, that's pretty good to cover most folks. The employer must ensure the HPDs are worn, and they must ensure proper initial fit. So this again goes to, we need to make sure that the earplugs that we're giving our folks are actually going to fit their particular ear canal, right? We can't just say, hey, it's a one size fits all. I promise you, as an earplug manufacturer, if we could get away with making just one earplug that worked for everyone, we would have done it a long time ago, but that's just not possible. And then the last piece of a hearing conservation program is a training piece, right? So employees must be trained on the purposes of HPDs, advantages, disadvantages, and attenuations of various types, instructions on selection, fitting, use, and care. And that also must be repeated annually. So we've got to make sure that we've tested our folks' hearing, we've given them protection, and that they know how to use that protection. This again is just a high-level overview of what hearing conservation programs entail. If you want a lot further detail, you can go into those OSHA regulations that are referenced, and they spell out every component. But if you can hit all 4 of these pieces, you're in good shape.
Perfect.
All right, so how do we insert an earplug? This is one of the things that I see happen wrong more than I see happen right. So I'll start from the bottom and kind of work our way up. There are 3 different styles of earplugs, okay? There's the reusable earplugs. There's what we call hybrid, like push-in foam earplugs. And then there's the ones that most of us are familiar with, the roll-down foam disposables. The bottom 2, the push-in hybrids and the truly reusables, are the easiest to insert. Step 1, we reach over our head with our opposite ear, we straighten out our ear canal, and we just insert the earplug. We push it in to get a fully seated, proper fit, and that's it. We let go and we're good. The most common earplugs we see are those roll-down foam disposables, and there are 2 extra steps in the insertion process. First, we have to, I like to make the joke, right? The first step is actually to wash your hands anytime you're using foam disposables, because it's the only PPE you wear inside your body. And as you'll see in step 2, we roll down that earplug to compress it. And so any germs that are on your hands are going to be put straight onto that earplug and then straight in your hand. So make sure you've got clean hands. Step 2 is to roll that earplug down. Now we say to roll, we don't pinch it, we don't squeeze it, we don't fold it, because if we roll, we want that foam to be able to expand once it's in our ear canal, all 360 degrees. If you pinch and fold, you might create some creases that actually leave gaps, allowing some of that sound energy to go through and not create a perfect seal. So once it's rolled down, you follow those same steps, reach over your head, insert the earplug all the way into your ear canal. And then the last step is you have to hold that in place. You have to allow that foam to expand, right? Physics tells us material will take the path of least resistance. If you don't hold that in place, the path of least resistance is straight back out your ear canal. So we got to hold it in place till it's fully expanded, fully seated, and create a proper seal. That can take anywhere from 15 to 40 seconds, depending on the size of the earplug you're using, your size of your ear canal, the recovery rate, the a whole bunch of different factors. But what we know for sure is that you don't just roll it down, stick it in, and go. We have to hold it in place to let it expand. All right, so this is a perfect example of why that's the case. Okay, so the image on the left, obviously, there's no protection there because he's not wearing anything. The image on the right is a properly seated earplug. If I'm looking at you face to face, I shouldn't be able to tell whether or not you're wearing foam disposable earplugs. The image in the middle is how we see most people wear their foam disposable earplugs. And I would argue that that is actually more dangerous than the gentleman on the left because you get a false sense of security. So Rob, if you click through, should show 0 decibels of attenuation up to 33. And the one in the middle is actually only getting anywhere between 2 and 5 decibels of attenuation. Why that's scary, right, is because we know that we've actually doubled or cut in half the amount of noise that's reaching our ear. If we're getting 3 or 5 decibels of attenuation, it sounds a lot quieter than if we're wearing nothing. So we think we're protected when really the facility that we're in, we need 10 decibels or 15 decibels of attenuation. So even though our brain perceives it as a lot quieter and protected, we are still drastically overexposed and causing potential injury. So we really want to make sure that we're actually inserting those earplugs properly and that our folks are trained on the proper way to do it. All right, next. All right, so what about NRRs? How do we calculate those? They really are just an estimate. Just because it says 33 on the box does not mean that this individual is going to get 33 protection. The way that they're calculated, a group of human subjects are brought into a lab. We test them. The attenuation results are averaged. That average is reduced a little bit to account for realistic field use. And then that's what becomes stamped as the NRR on the box. So that means that even in that group of test subjects, there are folks that were getting less protection than what was stated on the box. That is why it is so important that we do an individual fit test and actually validate and make sure that people are getting the protection level that they need. Next one. So what is fit testing, right? It's a method to discover personalized attenuation rating for specific HPDs for specific individuals. And that helps us understand how much protection employees are getting to make sure they're getting the level that they actually need for their specific situations. One more. All right, so we ran a case study a number of years ago on 146 workers using our VeriPro Systems Complete Check. What we did is we brought them in and we said, hey, put your earplugs in the way that you do normally on a day-to-day basis, and let's just test to see how protected you are. Only 17% of those folks were getting the protection level that they needed. We then trained them, didn't change their earplug, just taught them the right way to put earplugs in, and we were able to get that number up from 17 to 78%. The really interesting piece, though, is that still 2/3 of those people chose a different earplug after we did the test than before we did the test, mostly due to comfort of proper fit. Okay, just because we can get an earplug to fit you and provide you the proper protection doesn't mean that it's the right earplug for you. If it's not comfortable for you to wear for 3, 4, 5 hours straight while you're working all day, if it's not comfortable, the first thing people are going to do is either A, not wear it at all, or revert back to that image in that where we showed those 3 different ears to where it's sticking halfway out their ear. So what's really critical is that we get it to be a comfortable fit at the proper protection level. And we can only really do that by utilizing a fit testing methodology.
And maybe that's why OSHA goes back and makes that statement of a variety.
Yes.
There's a lot of variables in there. There's a lot of, like you said, the human body shape, size, and then most importantly, comfort. I'm sure from your experience, people that have comfortable hearing protection are far more likely to use it and think about it and really get into the habit of using good hearing protection.
That's exactly right. Spot on. It's the number one thing we can do to improve employee compliance with actually wearing their HPDs is give them something that is comfortable for them to wear.
Perfect.
Yep.
Well, yeah, I think we're at the 30 minutes. I don't know if we had any questions online, but or through the chat today. But thank you very much, Kevin. This is really informative. I personally learned a lot. I think the thing that, key takeaways for me is the accumulation of sound, not only in personal life, but in our work lives. And now we have to think about it differently and how it can build up over time, even when, your brain's not perceiving it's a problem. But also just the decibel level, like you said, the takeaway, it's exponential, and a few decibels can be pretty impactful to your overall hearing.
Absolutely. Absolutely.
So with that, for those like kind of next steps, next actions, if you have further questions or you want to know more from Steiner, we're happy to please contact your account manager or your inside sales representative. We're happy to schedule a local PIP expert to come out and kind of start looking at your facility, understanding what your needs are, and really kind of do a deeper assessment. Excuse me. Or if you don't know who your account manager or inside salesperson is, you can always call 1-800-Steiner. And with that, coming up July 15th from 11 to 11:30, we got John Redmond from Hoffman going to be talking about thermal audits. Kind of still related to safety, but that'll talk about life cycle, sustainability, and avoid potential safety issues as well. So thank you very much for the day, or for the time, Kevin, and very appreciate the education.
Absolutely. Thanks, Rob.
All right. Thank you.